we posed a question. We posed a question that we're going to ask that you respond to at the top of your page. No earbuds. Which would you rather have stepped on your foot? A 6,000-pound elephant or a 100-pound lady in high heels?
Oh, my feet.
That's not an option. Why?
Good thing your face isn't on it.
I grabbed two people's papers. I won't name their names. Area. The reason why we put this question here is because at the beginning of a unit by one of the professors at MIT, which is the Massachusetts Institute of Technology, the most prestigious college in the world for engineering, the professor poses this question, and over 80% of the students that go to this class miss it at the beginning of the class. And it's okay, he said, for you to miss it because everybody assumes that one would hurt less than the other. He then proceeds to explain through demonstrations, and through lectures, and through labs, the same thing that we're going to be doing in our unit, learning about this concept of pressure through experiences, demos, labs, and lectures, to be able to answer this question at the end. We're going to revisit this question at the end. Today our agenda will look something like this. All right, we're going to start with using pressure to push an egg into a bottle. I've got 2 eggs up there. We're going to use the same idea that we learned from that to crush the soda can. We're going to skip the third one, hammering a nail into my head, so that we will have time to walk on glass and for you to try and hurt me on a bed of nails. Okay? So, before we go any further, I need to make this disclaimer. Do not try any of this at home. Do not try any of this at home. I know our teachers here know that what we're doing. And if you mess up, if you don't put enough nails into a board, if you don't put enough glass into the box that you're going to step into, you will hurt yourself, and it could be fatal. So don't do any of this at home. I have 2 jars here. Each of them have an egg. The eggs are hard-boiled. The eggs by themselves will not go through, right? Now I can push them through, but I don't want to do that. I want to use the idea of pressure to push the egg in. Which one of these would you like for me to light up a piece of paper and try this?
The big one.
The big one? The small one? Who don't care? You guys are horrible. I heard the big one.
You already broke the microphone.
Being silly.
Light it up.
We're going to let that burn for a second. What's that doing in there to the air?
It's like
I saw that on YouTube.
What did that do to the air inside of that container? When I put that piece of burning paper into that Erlenmeyer flask, what did that do to the air that was inside of that flask?
Heated it?
Yeah, it heated it up, right? It heated it up. It was warmer inside than outside. Would you agree? Absolutely, absolutely. In chemistry, you'll learn that hotter things move faster. And because the hotter air inside of this flask was moving faster, it wanted to escape. It wanted to move to a cooler environment. Because it's moving out, that created lower pressure inside the flask than outside the flask. Does that make sense? Okay. Now there's 2 things happening. There's low pressure inside and high pressure outside. Because there's more pressure outside, the egg doesn't get sucked in, the air outside pushes it in. Okay? I'll give you about 3 minutes to write about that experiment. Again, this is how you are getting credit today. A picture works well, words are better. Right on. 1 minute. All right. All right, ladies and gentlemen, you've had an opportunity to write about what you saw in that first experiment. Now, what did we notice? What did we notice? We noticed that inside of that container, the air was hot or cold? Hot. It was hot. And the outside was cold, right? And what do we know about hot things now? Do they have high pressure or low pressure? Lower pressure, and the air outside of them. That's why the egg was sucked in. I've been heating up this can for about 30 minutes, and I put a little bit of water in it so that it would create steam, and it would push out all of the air that's inside of it. We're going to see if this works. I have a disclaimer at this point. My disclaimer is this. There's 3 major topics of science. If it stinks, it's biology. If it blows up, it's chemistry. And if it doesn't work right, it's physics. Exactly. Exactly. We got this to work last class period and part of third period to work. The other classes, this experiment didn't work. So, what should happen, now that we know that the inside of this is hot, and I'm going to put it in this ice cold water, what should happen? Let's see. You ready? It's going to go quickly. 3, 2, 1. And it crushed it. That was good. Did you see that? That was the best one of the day. Is it still hot? All right. We'll turn this on. Okay. Oh, heat up, right? All right. So, you now have a second line in your notes. The soda pop crush. The soda pop crush. What happened and why did it happen now that you know about high pressure? Right on. Exciting stuff. Good year. Bears. On.
Fatality.
Where was the high pressure?
He just hit it.
Why did he get crushed? Where was the high pressure? Inside or outside? All right, so make sure that you're writing that. For our 9th graders, these notes that you're taking today are going to be very, very helpful tomorrow. I don't know if your teachers have told you yet, but you'll be able to use these notes to aid you in your writing prompt. You know those monthly writing prompts? All right.
You go right, how to do jumping jacks?
It's not funny, just what you told me.
Where's the girl that you
Not
just
on
stood in
it.
towards the end?
It's just for us anyways.
Where's she at?
I'm like, they want to make sleep. I'm like, that one makes sleep.
Okay, I give you, I appreciate you.
That's what I like, was the extra. That's true. That's true. Hey, will you grab me a strip of paper towel? Paper towel.
Okay, it's not free, like this.
I need a volunteer. I need a volunteer. Right here. Come on up. Come on
I'll
up.
remember that for the
My-
next demo, okay?
When I was younger, your age, 14, 15 years old, my baby brother and I used to really enjoy going down to the stream, down the street from us, and going fishing. And I need you to just pick one and run it across there.
It's in his ear.
Okay? Anything, just pick one. There you go. All right. She's testing this glass to see if it's sharp. What do you think?
I think it's sharp.
Do you think it's sharp? I think it's sharp.
You know.
It'll cut right through. Go ahead and throw that back in there. You want to try
Where do you
it?
get that glass from?
Well, you think it's dull. Well, it's not a knife sharp, but it's sharp. It's sharp. You want to feel it? I did. That cut you? You stepped on it?
Whoa!
That's real.
Oh, he's stepping on.
Yeah, sure. Anyway, my baby brother and I used to go down. Thank you. Give her a hand, everybody.
You go, girl, you go. Make her proud.
We used to go to the stream and go fishing. Well, my baby brother never, ever liked to wear socks or shoes and socks. He would always go barefoot. And one day we're walking down to the fishing hole, and he steps on a piece of glass. It was a broken bottle, and he cut one of his toes clear off. Okay? I need a volunteer.
Tall. Who's
Tall.
all volunteer?
I'm tall.
Right there, I got
I'm
it.
tall.
Right there.
Go
I'm
ahead.
tall.
No, you're just helping it.
Yeah.
You're just helping it. That's all. But I don't like feet.
My feet are sexy.
Only to his wife.
I just need somebody to stay there. Yeah.
And you get to see his sexy white legs. Pasty.
If you have a cell phone and you would like to record this, you may.
Yeah, hold on, guys. He'll take your time, okay? He's gonna do exactly what you think he's gonna do.
Bro, she's not worth
Back in the
it.
day,
She's not worth it.
back in the day, I would do it. All right, there's two parts to this experiment. One part is much more dangerous than the other. We'll talk about both parts of this experiment as we're doing them. We will show you why one part is more dangerous than the other. If you're going to video, awesome. If you're going to text, not so much. All right.
Okay, oh, hold on. Wait just a minute.
Okay.
Also, guys, listen. Listen to what you're going to hear, because it's actually important.
She's not worth it.
Oh my god. Oh my god. I think I reacted. Oh my god.
Okay, good.
Emily? Emily?
Okay. Ah.
Okay.
Give her a
Ladies and
hand.
gentlemen. Did you guys hear the glass breaking? Okay. Do you think that was a good thing or a bad thing?
Good thing. Good.
Ooh, I kind of hear half and half. I hear good thing, bad thing, good thing, bad thing.
Whoa.
Mr. Miller, what do you think? Is it a good thing or a bad thing?
I'm hoping that it's a good thing.
Okay, remember the story he told you about his brother? How many bottles did his brother step on?
One.
One, and he cut off his toe. How many bottles do you think Mr. Miller's standing on?
45. 80.
Maybe like 50?
What?
80.
Is it a lot of pieces?
Are you videoing or touching? Okay.
So guys, he's stepping on a lot of pieces, right? So what are all those pieces of glass doing to his weight, to his mass?
Llorando.
They're supporting him.
No pain.
Okay, they're supporting him, but how? What way?
Surface area.
Okay, what about surface area?
Giving him more stuff on.
Have you seen these? I just had a pedicure 2 days ago.
Yes, sir. Very good. Everybody here? Okay, say it one more
Say
time.
it loud.
He's not putting all of his weight on one, or he's not putting all of the weight on one piece of glass. He's putting on all of it.
Right, ladies and gentlemen, his weight, his mass is being equally distributed to all those pieces of glass. He's not putting all his pressure on one piece of glass, so it's not cutting his feet. Unlike his brother, who stepped on one shard of glass and it cut his toe off. Okay? All right, now we need a, yeah, here we go. Okay, Mr. Miller getting out of the glass, guys, is actually the dangerous part. Can anybody think why?
Because he's putting his pressure on one part.
Oh, okay, I did hear someone say he's going to put all the pressure on one foot. What else?
Keep on cut himself.
Okay. Glass is going to get stuck to his feet. Guys, have you ever broken a glass at home and cleaned up all the shards and you missed that one teeny tiny little one? And you step on it, what happens? Yeah. People just said it cuts your feet, you draw blood, because all the pressure was on one piece. Okay?
I'm dead.
Okay, can you guys see the shards stuck on the bottom of his feet? Okay, so he's going to use the towel and kind of wipe them off. He'll show you guys over here in just a second, okay? Because he doesn't want to step on this table with any glass shards on the bottom of his feet because it will cut his feet. Okay?
That's okay.
But ladies and gentlemen, this is how people are able to walk on glass. It does not hurt you. The more part you have to get over is the mental part.
Give him a hand.
So at this point, you should be filling out that next one. And that next one where I was standing in or walking in glass. In your description, you need to talk about area and how the area helped me be able to do this. How did the area, did I increase the area or decrease the area by stepping on a lot of different pieces?
I'm dead.
Excuse me.
I wouldn't say my pressure, I would say Hey, I have a question. I have a question. A few weeks back, you guys learned the difference between mass and weight. Right? Is weight a force? Is weight a force? Yes, weight is a force. So I put my force, my weight, over an area. And I was able to not get cut. What if that was a smaller area? What would that do to my pressure? It would cut me. It would increase the pressure and cut me, right? So did I have was there a lot of area that my feet were on? Yeah. I need 1, 2, 3, 4, 5 volunteers. 1, 2, 3, 4, 5. 5 volunteers. Not yet. Finish up your writing for this piece. We're not doing the walk on glass. Oh, did we do the disclaimer? And this slide's the most important slide you're going to see all day. Don't try this at home.
I'm good. Don't be back.
I think we forgot to do that earlier. Oops. 30 seconds.
Here. You sort of have to. Straight up, hey, remember, he has 2 awards for that. 2 awards.
10, 9, 7, 3, 2,
Well, for what?
1. Who was my first volunteer? Right, come on.
We record this?
I need for you to test these nails to see if they're sharp and real.